So I apologize, there is going to be a lot of code in this presentation, but I promise that even though it's 3:30, it's going to be relatively easy code, but to keep you awake, there will be some gotchas. If you saw the last talk, there was a little bit of an allusion to what I'm going to be talking about in this one. If you had a sharp eye, you would have noticed one of the slides had ancestors and callers. So I don't know if anybody noticed that. But now you get to find out what they are. Okay, who here knows what ancestors and callers are? Oh, okay, so maybe about like 5%? And how many of you know how it's used in Elixir? So it's like 2, 3, okay, great. Then I've got a good audience. All right, so this is like one of the best kept secrets about Elixir. So I'm really excited to show you guys interactively what's going on. This was a feature that I believe came out in Elixir 1.8, don't quote me on that. There was one line in the release notes and I believe one quick comment on it at the ElixirConf, at some presentation at ElixirConf, and I've not seen anything else online about it. So here we go. So the subtitle of this is a deep dive into how Elixir makes OTP awesomer. All right, so we're gonna have to level set on some Beam background information. Most of you probably know this, but it's worth it to go over. What is a process? A process, so I don't like the people who say actors. A process is the atomic failure domain unit in the Beam. And it looks like an actor in this sense. It encapsulates a single execution thread as a stack, a heap, a message queue, and it has an instruction pointer. So let's do a quick demo on that. So here I've got a test, right? And basically what I'm going to do is I'm going to spawn, which is the system call that creates a new process, right? And you pass it a lambda, and that lambda gets executed. It can close in on other variables that exceed on the outside. And this should be pretty straightforward, right? We're going to see the spawn task say hi from spawn, and the main test task say hi from test. Well, let's see what happens. And I need to do this. All right, so did that happen? Yes, it happened. But the thing that we have to be careful of is that sometimes it doesn't happen. So here we see that the hi from spawn didn't happen. And why did that happen? Why do we have this behavior? The reason why we have this behavior is that the spawn here winds up taking too long, maybe because this do some work is really taking some time. And the outside test finishes, and then we don't get to see it print out to the I/O. It just kind of gets lost because the VM finishes up. I'm done running your tests. No more need to print high spawn. So how do we fix this? Well, we have to basically create a mutex, which is a little bit of a scary way of saying it, but we need to coordinate these two processes. So here's how I'm going to do it. We're going to set a variable called this test. We're going to assign it to the PID of the test. And remember, in Elixir, Elixir and Erlang, all execution happens in the context of some thread or some process, right? And so we're going to save the PID for that, and then we're going to send an unblock message to the test PID, and then we're not going to finish running the test until it receives that unblock message. Okay, pretty straightforward. And when we run it, we see pretty consistently we get both of them. Now, if we run enough times, we'll probably see a situation where it's not cooperating with me, where they're in flipped order. Okay, well, it's not cooperating with me. Oh, there we go. Flipped order, finally. It's random, right? So I randomized how much time that do some work waits for. Okay, so we have coordination now, but we still have out of order. And so this is what's known in the distributed systems biz as a race condition. And you just have to watch out for that all over the place in our highly concurrent Elixir system. Okay, but that's not all. So we also have something special. What happened here? Oh, okay, so here we go. It's more than that. The Beam comes with something called a process dictionary. Okay, what this is a local mutable KV store that only the process can see. Think of it as if each Beam process has its own instance of Redis attached to it and running, which is really cool, right? The lifetime of this KV store is the lifetime of the process. So when the process dies, that KV store goes bye-bye. And you saw in the previous talk how spandex uses the process dictionary. Now, if you talk to anybody who's like really experienced in Elixir and Erlang, they say don't use the process dictionary. Yeah, because it can be really hard to reason about like what the lifetimes of these things are and whether or not that's appropriate for your use case. So with that caveat, let's go deeper into the process dictionary and its role in something that almost all of you have probably dealt with at some point or another. Okay, yeah, so before that, we need to look at some mechanics of this. So there's this process module, and it's got a put and get, right? And here, what I'm going to do is I'm going to put just something called a key called location with a value spawn, and then I'm going to get it and then do the io.puts with that value, right? So that's pretty straightforward, and then we're going to do exactly the same thing in the outside test. So let's take a look at the result. And what you'll see here is that there's a test and a spawn and a test and a spawn, right? If these were like truly like global mutables, then you would see test, spawn, spawn, spawn. But this demonstrates that indeed each process has its own local only knowledge of what exists in its own process dictionary. Okay. So let's look at databases. So I've written this database test. It's pretty simple. This is just a plain old ecto repo. I'm going to insert some data with value foo. I'm going to do some work, which will take a random amount of time. And I'm going to assert that is the singleton that exists inside that database. Do some more work, and delete the repo, or delete the data from the repo. I'm going to do the exact same thing with database 2, except it's going to be bar. All right, anybody have any idea what's going to happen? Just think about it for a moment. Good guess, good guess. No. 2 green dots, okay. Why did we get 2 green dots? Well, if you look at this, these are not asynchronously running tests. So each test checks out the whole database that it's connected to, and then runs it. And it does whether or not the first one is running then the second one or second one. One thing to know about how Elixir structures its tests is that each module randomizes the order of their tests inside, which doesn't matter in this case because we only have one test. But and it randomizes the order for not async tests. It randomizes the order in which the modules get run. In this case, they're not async. So the database 1 does its thing. It deletes the data, and then we have an empty database again, right? And then similarly with database 2. The second test, we do exactly the same thing and everything's hunky-dory. Okay. So I just mentioned, though, what happens if we try to make it async. And now we are going to get the error that you expect. We're going to get a race condition, right? So, and let's see what that looks like. Here, boom, we see that the assertion fails because there are 2 pieces of data in the database. Now, when you use XUnit in this situation, this data persists inside of the database. It just stays there. So let's go ahead and clear that up. Oh, maybe I can do this. Okay, didn't do it. So let's clear our database, and then so we can move on. Okay, so how do we fix it so that we can actually do asynchronous tests on our databases? Because we do want our tests run asynchronously. That way we don't have to wait for one test to finish before they're going on. And this is really important because integration tests tend to be slow, and if we can parallelize them, that's even better. The side benefit is that you're just exercising your VM, so you have higher confidence that what you're running is much more robust. So the way you do this is in your test, you set up your SQL adapters to use sandbox mode. And what that means is that when your test is capable of checking out a transaction, right? and then that transaction lasts for the lifetime of the test. At the end of the test, the transaction is rolled back, and at the end we should have basically the same database that we started out with before. But because they're also in transactions, if two tests run at the same time, then they're not going to trip over each other. They're going to see their own like universe of what the database should look like. And we also have to do something on this side. We have to add these setup, do, ecto adapters, SQ sandbox checkout. This is what takes the sandbox and checks it out, creates a transaction, and then binds all of the code that's inside of the test to that sandbox. All right, so let's run this. And great, we get 2 green dots. All right. So the other thing we know now is that the database checkouts are tied to the process of the test. And what we're going to do for the rest of this talk is unpack how that gets done, and then we'll learn a little bit about the process dictionary. OK, so one more thing is that remember, since the lifetime of the checkout is since the lifetime of the transaction is tied to the lifetime of the process, right? We actually don't need to bother deleting because once the test ends, everything gets rolled back. So just to show you, we're going to run this one, and you'll see that we get 2 green dots, and it complains a little bit that the data is not there, but like we don't have to worry that there's any content left over in the database because it's been cleared out, or it never actually hit the database. It was in a transaction that got rolled back. My belief is that you should be running as many of your tests as feasibly possible using this as sort of like a guide. You want to set up these ecto sandboxes, and you want to check them out and then run your tests async. I think it's a really good idea, and I think that's uncontroversial. Okay, but if you do this, you're going to eventually run into some weird errors. So let's take a look at one. So in this case, I am doing just one test that accesses the database. It basically looks more or less the same. We're asserting that the data, that the value exists here, and we're spawn linking a process. All right, now, so yeah, this isn't a test, like, okay, weird. But like, this could also be hidden behind a function call that you're testing, right? So that function call could spawn another process. And if we believe that the process IDs for the processes are what associates with the database checkout, then we would expect this thing to fail, right? So let's test it. And yep, so many of you have probably seen this error at least once and possibly scratched your head being like, what the hell is going on? It's got this like characteristic for asterisks. Oh my God, what's going on? I don't know what's happening. Sometimes even if you have very well-formed tests, this will kind of sporadically happen. If like you have a weird race condition in one of your other tests failing, it could somehow wind up triggering this to happen. So it's pretty common to see this if you're using the asynchronous tests. So what is going on here? Well, exactly as I said, the PID is associated with the database checkout, and that is no longer the same PID because we spawned a new process to do the database access. Okay, so one of the guidelines that it said was you can pass it as caller, right? So we can do this, which is to just literally take the PID of the test and assign it as this caller, and maybe it's not an accident. This is called caller. And that will fix the issue. I'm going to go ahead and demonstrate that right now. But I don't think this is like really a good solution because it works fine when the spawn event happens inside of the test. But suppose it happens in your library code, you might have to like drill like that caller parameter several layers into as options, and that's not really fun. You're basically getting a leaky abstraction over the Elixir API. So maybe there's like a better way to do it. Well, let's take a look at what the better way is. The better way to do it is to use task. So instead of using just a naked spawn, Elixir has this wonderful library called wonderful module called task, which I'll get into like my opinions of how we should think about task later. But let's go ahead and just run this and see what happens. Oh, right, sorry, wrong test. We're in task test. All right, so let's run task and green dot. Wonderful. Okay, so that's weird. Like, how did this work out? Like, how does it know what it's supposed to do? Well, I said that we would take a look at the process dictionary. And so what I'm going to do is I'm going to inspect the process ID of the parent test, and then I'm going to just blat out the entire process dictionary, which is this process.get with zero arity function, and we'll see what's going on. Great. So we see the PID of the test is 599, and we have here in this ancestors and callers process dictionary. We're going to ignore ancestors for now. I'll come back to that later. We see that PID. Okay, so we now kind of have this hypothesis that maybe, and I did say that this was going to be like a science and hypothesis-driven talk. Maybe this is how it knows which repo to connect to, which repo checkout to connect to. So let's see. Well, the obvious thing to do is to, oops. What happened? Oh, I think I just duplicated this slide. Oh, sorry. No, I do want to go one deeper. Let's go back. In this case, I have two nested tasks. So this one on the outside and this one on the inside. And then we're going to inspect the PIDs of both the outside task and the first outside task. And then we're going to take a look at the process dictionary of the inside task. And I use task.async just to prove to you that, like, yeah, this works for all things inside the task in the task module. All right, so let's take a look at that again. And so here you see that the caller's keyword, or the caller's process dictionary value has two things in the list, and it's the parent test, or it's the immediate parent followed by the outsidemost process. Okay, and of course it works. So somehow the database repo is like maybe looking down this callers list and identifying, oh, at the end we have this PID that I know about, and that's how I can connect you to the checkout that you need. So let's test this. Right? We're scientists. We gotta come up with a test. So here's what we're gonna do. We're gonna nuke that value. Process.delete $callers. Okay. So let's do it. Boom. We get an error, and we get the exact same error that we got before. It's actually twice because this is start link. Cool? All right. Now we should also do the converse experiment to prove that this is both a necessary condition and a sufficient condition. So here's what we're going to do. We're going to use spawn link, which didn't work before. And we're going to put a caller's value into spawn link, and we're going to set it to what it should have been if it were task. Okay. So spawn test. Oh, that didn't work. Oh, good catch. Awesome. I'm so glad somebody saw that. All right, let's do this. All right, yeah, right, because I put the wrong thing in the process dictionary. I'm glad you guys are paying attention. And then let's run it. And green dot, great. We're going to have a little bit of a leaky abstraction here. Okay. All right, so let's move on. Okay, so I think this is pretty good evidence that what's going on with these tasks is how the database checkouts are able to know where they belong is by using the caller's process dictionary value. I do want to spend just a moment to talk about ancestor. Ancestor is something that exists in Erlang. Callers does not exist in Erlang. It is Elixir only. And callers, the reason why it was created was inspired by what ancestors do. And to show you kind of like the most concrete way of showing what an ancestor is, I'm going to create a gen server inside this test. It's just going to do something really stupid, just initialize itself and then keep running. and then I'm going to ping, and then I'm going to return, I'm just going to inspect the process.get, right, from here. So I'm just going to call this, and then we're going to see what we're going to see on I/O what it was. And here you can see that when it's a gen server, you have this ancestors. There's two PIDs. One is the supervisor that I ran here, and the other one is the actual test. So basically, what ancestor does is it allows the running process to keep track of where it came from in the universe of the beam. I actually honestly don't know what it's used for beyond that. But I suspect it's important, otherwise they wouldn't have included it. All right, so let's talk about mocks. So what do you expect? Mocks ought to work exactly the same way. So here we have an async test. I'm just going to expect this mocked module to call, and then it's with zero arity, we're going to return OK, and then we're going to spawn link. So we expect mocks to choke on this, right? It won't know, because this PID is detached from the test PID, it will say, I don't know what you're expecting out of this module. And sure enough, we see this problem where it says mocks unexpected call error. No expectation defined for mocked call in the process PID 600, which is this internal spawn link PID. All right, let's move on. We can do the exact same opposite experiment that we did, which is to manually put in the callers into the spawn link, and we would expect to see all of a sudden mocks work. Green dot. Okay, let's do task. So task, it's exactly the same, except instead of start link, it's our spawn link, it's task.start link. And let's just go ahead and run this. And green dot. And then if we go on and we delete the caller's key value, and we run it, hey, mocks unexpected call error. So both mocks and ecto use this caller's value in the process dictionary to know where they come from, but not in a supervised sense. In a who created the task. Now, for all of these situations, you've seen that the ancestors were the same as the callers, and that's because we've been doing a naked task call. If, however, we did task.supervisor, the ancestor would be the supervisor process, and the caller would be the caller that called task.supervisor. And I think that this is the reason why in Elixir 1.8, they decided they needed a different abstraction than ancestors to track where these tasks are coming from. And you should supervise all of your tasks. So I'm going to pull one more rabbit out of my hat. We are going to leave the Beam virtual machine and still be able to do these tricks. So here I have got a really basic router, a plug router, because Phoenix is just a little bit more complicated. This is pretty simple. It just does what you expect. When you hit the root path, it's going to look up data in the. It's going to look up the database and then return whatever it sees inside of the database. Okay, so and here's the associated test. So what I'm going to do is I'm just going to insert a value into the database, right? And then I'm just going to hit it with rec. That's Wojtek Mach's HTTP client. So you would expect body to be foo, right? That's what we saw. Well, of course, we wouldn't be talking about this if it didn't fail, and we see a 500 error, right? Well, why is it a 500 error? Because if we look up here, basically what happened was, once again, those 4 asterisks test. It couldn't find the checkout. It freaked out, crashed the Phoenix process, and returned to 500, because that's what happens when you crash a process in Phoenix. Okay. So how are we going to fix this? Well, I'm going to write a plug, and what this plug is going to do it's going to look in the request headers for a value that I'm going to put in there called callers. And then this is going to be a base 64 encoded value. And then I'm going to convert it to binary to term. And I'm just going to take that and drop it straight into the caller. So now I need to figure out how to get callers into there. Okay? Pretty straightforward. One note. Well, let me go ahead and go to the next slide first. So then we're going to put that plug in the router. One note is that if you are deploying to prod, do not have something like this in there, because Erlang binary to term is dangerous and a security regression. Please, 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 whatever you do, if you do something like this, put it around an if, like, if mix env equals test. Otherwise, no bueno. Yeah, so let's go ahead and see what happens. Right. Okay. So in our test now, we have to instrument that header in the HTTP request, and that's just basically a process of doing the exact reverse. I'm just gonna try and find the callers value, or wrap it in a list, wrap self in a list, and then encode it term to binary and encode 64 it. So that's what I'm gonna do here, and then here you can see me pass it in the headers using rec. Oh, great. And you can see green dot. So this is actually the strategy that Hound and Wallaby use. I don't think they use callers. They might stuff it in one of them, I think, at least one of them stuffs it in the user agent. Whatever, do it how you will. This is one way to get really, really robust tests that are full integration tests that start out. Your test starts inside the Beam VM. It leaves the Beam VM by issuing an HTTP request. That's over a TCP/IP socket or maybe a loopback socket, and back into Phoenix, comes back in, and then the adopt callers plug will then hook it in and let the test suite and let the Ecto sandboxes and the mocks checkouts know, mocks expectations know who I should be retrieving these key pieces of information from in order to do my job. Okay, so a few concluding statements. In general, you want to be careful about race conditions, especially when you start doing async tests. Everybody runs into them eventually. And in particular, be careful that the lifetime of your task might overshoot the lifetime of the test. So if your task is taking a long time to run, right, and then it tries to access the database and it has something in callers that's stale, it's going to say, I don't know. What should I do? I don't see this PID. Can we use this outside of testing? I wrote yes, but I'm going to say maybe. I have demos that I didn't feel like I had time to talk about. One where it's used for database dynamic repo, which is where you can assign the database repo to something else sneakily. That could be like a sharded database or a mirror database, or like maybe like a machine learning database versus the primary database or secondary database. The dynamic repo thing is, it's actually kind of experimental, and it may not last in Ecto, who knows. And then one thing I'm kind of maybe interested in is some sort of CBAC-based authorization tracking, where you can store these in some sort of registry, and the registry will remember what the CBAC token is for your process, or look through your callers list and see if I am inheriting a token, a CBAC token. Oh, sorry, CBAC, capabilities-based access control. So it's not like not what most people use for access control. All right, a few more concluding statements. Elixir tasks are special. They really add new dimensions to process management. This is where I'm going to get on my high horse. They track callers, which is inspired by OTP ancestors, and you should think of them as an extension to OTP. There are also more goodies that task gives you, like task.supervisor. In my opinion, you should always use task over spawn, and you should probably also always use task.supervisor. And my maybe controversial opinion is that maybe Erlang should get a task module. Okay, that's it. You can find me on Twitter at Dianotics. I want to shout out to two companies. VicAI is my former employer. They do machine learning orchestration with Elixir for invoice processing. So you take an invoice and then you figure out what accounting information goes with it. And 3 weeks ago, and they're fantastic. I feel really bad for leaving them, and it's really the best place I've ever worked. So, and they're basically fully remote. So apply for their positions. I now work for iconbuild.com, which is a 3D house printing company, which is not an Elixir company yet, but hopefully in the next, well, not yet. Yeah, so yeah, that's it. Oh, thank you guys for coming and paying attention to this talk with a lot of code.